Hello, Assalamu alaikum. Bismillahir Rahmanir Rahim. Welcome to Mathematics School. This is a lecture on S1 designed for basically A-level students. So this is the very first lecture actually on these course. So I think if you just listen to the lectures and follow the instructions and slides, then you will be able to understand uh, every topic very clearly. So today we are starting our lecture, starting from first one, that is the lecture one. So I'm going to just share my slides here with all of you guys. So I hope this will be enjoyable and you'll be very much interested to listening to the further lectures. Okay, so let's see what is in this slide today. Okay, so the first lecture is designed by statistical modeling. Now, question is, what is the statistical modeling? A statistical modeling is a simplification of a real-world situation. It can be used to make predictions about a real-world problem. By analyzing and refining the model, an improved understanding may be obtained. Okay, so what do you understand by that? Okay, if we just try to explain the definition, then we see that in our daily life, that is every day we are having some problems. We need to, deal with many uh, daily life problems. Say you are going to, you know, uh, arrange some foods for a guest at your home, or maybe you're planning for, uh, you know, future about a journey or tour to some country or whatever. So if you think about a state of a country, then a country has to, deal with a lot of things. A country has to plan for the future. They have to, solve problems of the citizens. So everything is done actually one kind of estimation. Actually, statistical analysis is very important over there. So statistical model actually helps us to simplify our problem, and when we are analyzing a problem, then we have to set a model first. That means we have to make some statistical procedure or some mathematical procedure, and any kind of procedure is done by one kind of modeling. So later on, you will understand what kind of modeling we can set for solving a problem. Uh, and when a model is set to solve a certain problem, then that model may not be exactly suitable for the situation or to solve the problem appropriately. So in that case, the model may require a refinement. So that means uh, we proceed on with the model, then when we find any problem in the model, and if we see the result is not coming to our expectation or it's not realistic, in that case we need to refine the model in some part of the model, or maybe sometimes we have to change the full model. Okay, so that is statistical modeling. So statistical model, basically what does it do? Let's see. There are some advantages here. A model is quick and easy to produce. That means when a model we are going to set, it saves our time and it's make everything easy. So first of all, the model helps us to quicken the situation and to make it easily. I mean, to solve it out easily, and procedure should be in a appropriate way. That is, the situation is not random or haphazard. It is in a systematic way. That's why it is easy to produce. The model helps our understanding of the real world problem. So of course, the model is very helpful to understand a problem. Say when a cricket match is going on, if you want to see the summary of the match, then we see some histogram or bar diagram uh, of different uh, overs of the whole inning. That means when an innings actually is analyzed, then we use some statistical modeling, say histogram, or maybe a cumulative frequency curve, okay, or maybe bar chart or sometimes pie charts, just to compare between two innings of both teams. So it helps us to understand the problem easily. Next is the model helps us to make predictions. Yeah, of course. For future forecasting, we need to just see the analysis of the model, and if we see that the prediction is, I mean, to be made easily, I mean, accurately, or maybe near to the accuracy. So in that case, we need to get the help of the statistical model. A model helps us to control a situation, railway timetables, air traffic control, etc. That means when there is a time series analysis or we have a data of past situations of different times, then in that case, analyzing the records, past records, we can set some kind of softwares or we can design uh, the timetable of railway or in air traffic. That means a statistical analysis uh, in a certain model helps us to make a software uh, more realistic and more appropriate. Okay, disadvantages: the model simplifies the situation and only describes a part of the real world problem. That means um, a model simplifies the situation. That means there may be some kind of difficulties or any in a sophisticated part in a certain situation which is not being described by the model. So it is simplifying it as a whole, but there might be some situations or maybe some, you know, facts that is not being, may not be described by the model. So, or maybe that means it may describe as a part of the model, not the whole situation. Sometimes it may happen. So it is one kind of disadvantage. Then the model may only work in certain situations or for a particular range of values. That means the model may not be appropriate for any kind. I mean, all situations. It is, say, if I take some data in winter, those data actually may not be appropriate in the summer. So, situation may not permit the model to fit in all time. So that means uh, it is there is a limitation of the model in situation to situation, and also for the values of, I mean, the data may not be appropriate all the time. There may be some outliers or maybe some extreme data that we need to actually uh, you know filter out. So that is the disadvantages of the model. Okay, so now here variables. Actually, in general, we call data, and variables is actually it's a formal name of data here. So qualitative variables, that is qualitative data. Actually, data is not always numerical. um, we understand that maybe data is always something, some numbers. Actually, uh, the names, I mean attributes, a noun or an adjective may be data. Say red, blue, or long, short, a country's name, a city's name. Say, for example, in a certain group of students, if I ask that how many of you like red, so 5 students may raise their hand that they like red. How many of you like blue? So 7 students are liking blue, say, and green, say 10 students are liking green. So and so on. So that means here red is data, and against it there is a value 5 who are liking red. This 5 is the frequency. Blue, it's against the blue there is a number 7. I mean 7 people are liking blue, so 7 is a number which is a frequency of blue. And green, it's against there is a value, I mean 10. That means 10 people are liking blue. So 10 is a frequency for green. I mean, sorry, green. 10 people are liking green. So 10 is a frequency for green. So that means if we want to draw a pie chart, so we can draw a pie chart for, red, blue, and green. So that means red, blue, and green are data, and the numbers 5, 7, 10, these are frequencies, and following this frequency, we will just uh, find out the magnitude of the sector of the pie chart. So if you want to similarly draw a bar diagram, we will draw some bars. For red, a bar, for a blue, for blue there would be a bar, for green there would be a bar, and how much height of the bar would be there. That is 5, 7, and 10. So that means we see here that red, blue, green, or any kind of name can be also data. That means data can be non-numerical. These kind of data are actually called qualitative data or qualitative variables. Quantitative variables or quantitative data, what is that? That is, length. Length means always we know some numerical values. Say 5 feet, 5 centimeter, 10 centimeter, 12 centimeters, age, so 10 years, 20 years, 40 years, or time, that is seconds or in hour. These are all numerical values. So number of coins of some people's pockets. So that is also a value. That I have 5 coins. Someone has 50 pence coins, 250 pence coins, 10 50 pence coins, or maybe uh, um, 5 pence coins. So these are 5, 10. These are actually values, and how many coins are there? That is the frequency. So anyways, so quantitative data is numerical data, and that means where the data are basically represented by some numbers. Okay, basically we'll deal with quantitative data mostly. Okay, continuous variables. So actually, quantitative data is basically divided into two types. That is, there are two types of quantitative data. One is continuous, another is discrete. So a continuous data or continuous variable is that the data which can take any value. Say height. Height can be any value, but for a certain range, of course. So if I say the height of human being. So human being, when an infant baby takes part, the height of the baby is maybe say 1 feet, or maybe 1.2 feet. And when a person, the baby is grown up, when it becomes an adult, then maybe his or her height is 6 feet or something like that. So in between, that means 1.2 feet to 6 feet. When he is growing or she's growing, her height is getting any value between this range, 1.2 feet to 6 feet. So that means this height is a continuous data. That means it can take any value of in a certain range, in a given range. Okay. So time can be any value. So 1.2 seconds, 2.5 hours, 3.6 minutes, any value. So time in a certain range. Say in an Olympic Games, say 100 meter in a 100-meter sprint, maybe the lowest record is, say for example, 9 seconds. The highest record is 12 seconds. So when a race is going to happen for next time, maybe we can predict that, okay, the you know uh, the participants will finish their race within the time of 9 seconds to 12 seconds, so within any time of from 9 seconds to 12 seconds. So the value may be any value from 9 seconds to 12 seconds. So it is a continuous value. But discrete data, there is numerical data too, but it cannot be any value in a certain range, of course, but not in any value. So shoe size. If I go to a, shop to buy shoes, then if I ask that I want a shoe of 10 size, they may give us. But if I say 10.5 size, they may not be able to give us the shoe, because the shoe company makes shoe of a certain sizes. For example, size number 2, size number 4, size number 6, size number 8, size number 10, but they will not make a shoe for 2.7 size or 2.8 size or 3.5 size. So that means shoe size, a factory, when a shoe factory makes their shoes, they follow some particular sizes, and those size has some particular values. So this shoe size is nothing but a discrete data, because you cannot have any value for shoe size. That is fixed value or particular values. Similarly, cost. So when we are actually going to buy, we are going to buy something from a shop. If it is the shop fix their price, then what happens? The prices are fixed. So that means, say a shirt, price of a shirt is written, say $10, and then another shirt is $15, another shirt is $20, another shirt is $18. If I ask the shopkeepers to give me a shirt of, say, $12, they may not be able to give us, because they may not have a shirt of price $12. So that means, or $12.5, or $13.5, or $14.7. Actually, they have some fixed price. They may have decided that, okay, we'll sell our shirts only for these prices. So these fixed prices are only available over there. So these are then discrete data. So you cannot have the price. You cannot ask for any kind of price if you want to buy. You have to follow the given price, or you have to buy the shirt or things from the shop for the, I mean, at the given price decided by the shopkeeper or the businessman. So, okay. So now this is what about presentation of data here. So when we are having numerical data, continuous or discrete, so then we have to present the data. There are many statistical procedures to present the data. And here in O level, you have learned some, I mean, methods, say um, uh, frequency distribution. Then you have learned, the process of I mean, basically frequency, yeah, group frequency table you have just learned, nothing else for presentation of data. But the graphical presentations, there were, say, histogram, bar diagram, pie chart, yeah, cumulative frequency curve. You have learned something like some methods over there. But here we are going to learn a new method of to present the data, which is called stem and leaf diagram. And when we are given some random data, say here we are given some data of 30 students, is scores of math test of 30 students, it's given here. And if we want to present it by using a stem and leaf diagram, then a stem, basically, that is a tree has a stem, a plant has a stem, and from the stem, leaf grows to, to one side or to many sides. So here we are using leaves to just to one side, to the right side. So leaves are actually carrying the data, which are data, I mean, unit place value of every data. That means, and the 10 place value is actually staying in the stem. That means when you are picking the data or putting the data in the system and leaf diagram, first of all, you have to make a stem. Stem is basically considered by considering the 10 value, 10 place value. So what is 10 place value? Where you see in this here 6, then 5, then 6, then 8, then 8, then 7, then 4. So these are 10 place values. So we have to see what is the lowest value of the 10 place value and what is the highest of the 10 place value. In this set of data, 40 may be the lowest value. So 4 is the 10 place value, which is the lowest one. And the highest value is 81. So 8 is the highest 10 place value. So we are going to create a stem starting from 4 to 8. So here the stem is 4, 5, 6, 7, 8. You see here 4, 5, 6, 7, and 8. And now for 4, for the stem 4, we are now putting all the unit place value, which is in the 10 of 4. I mean, all the data which are in 40s. That is 44, 49, 40, 47. These are all here we see. So the unit place here for 44, say 4 is the unit place value here, 4. So we are putting 4 here. Then 49, we are taking 9 is 9 here. Then 0, 40, we are taking 0 here in the leaf. then 747, then we are taking 7. For 5, there are data say 58, so I'm taking 5 stem is here. So 8 is there, then 53, then 3 is there, and so on. So thus for every stem we have to just take the unit place value for the respective stem, and this is how you can just make a stem and leaf diagram. Now to make it more clear, let's see another example here over here. So first, this is a record of data of 22 students in a certain math test. So the lowest value is here actually 10. We see 10 is the lowest value, and the highest value is here 91. So the stem will start from 1. The lowest unit place value is 1, and highest unit place value, sorry, 10 place value is 1, and highest 10 place value is 9 here. So we are starting our stem from 1 to 9. So 1, the stem we are creating, we have to draw a long, line here, long a vertical line, and to the left side of the vertical line we'll just create the stem. So 1 2 3 4 5 6 7 8 9, and to the right side of the vertical line in the leaf part, we are creating leaf here. And for 1, now say here for 1, let's see, 0 is there, so I'm putting 0. Then for 1 there is a 14, so 4 I'm taking 4 here. Then for 2 stem there is actually no data on 20s, so we cannot put any value in the leaf of 2 in the stem, against the stem 2, because there is no value of 20. So if there is no value, we should leave it blank. You could not put any, don't put 0, because if you put 0 it will represent 20. So 20, there is no data, so you have to leave it blank. So don't put 0, remember it. There is a common mistake, student makes this kind of mistake sometimes. So now next, 3 stem, you see the 32 is the data here, 32. So 32, so for 32 we are putting 2 here. Then there is the data 39. Okay, so for 39 I'm putting, you see, where is 39? Okay, yeah, here 39, so I'm putting 9 here. So when I'm taking the value, I have to just cross out the data from the table. Okay, so that no data is missed out, or no data is taken twice or more time. So we have to always cross out the data when I'm picking from the table. Okay, so now thus for every stem, thus we will put all the unit place value, like in this table you see. So basically, when we are picking the data like this, there might be a problem. That is, our data in the leaf, all the values are not in a systematic way. That means in ordered value, that is not in ascending or descending order. Basically, the rule is we have to keep the data in the leaf in ordered way. That means basically ascending order. That means we have to rearrange them. So in the next table here, numerically ordered, you see, we ordered every value in ascending way, so ascendingly. So say for example here, 6 was ordered already, 7. Yeah, 9, 8, 5, 5, 4. So we had to order it. So 4, 5, 5, 8, 9. So these are ordered ascendingly. Similarly, for stem 8, 70830. So we ordered it 00378. So this is the way we can make the ordered data in ascending way, and thus our stem and leaf is actually done properly. Now, one more thing to do, to the leaf, in the for every leaf we have to write down to the right side, a bit away from the leaf. We'll just write in bracket. In first bracket, we write down the number of data. So in first leaf, there are 2 data. In second leaf, there is no data, so it's 0. You see in bracket. So then in third stem, third leaf, there are 2 data, 2 and 9. Then in fourth leaf, there are 2 data, 2. So this is the thing that we have to always write down. And this is kind of mentioning the frequencies actually for every leaf. So in the first bracket, you see to the right of every leaf, a bit away from the leaf, we'll just make a vertical column, writing down all the frequencies and keeping them in bracket, especially in first bracket. Okay, and we have to finally write down a key. Okay, so these are the frequencies here you see. Then we have to write down a key. Key means, that means, for example, I have written a key here for a vertical bar, then 5. So for a vertical bar, 5 means 45. So actually 45 was the data, in the table. We just wrote it like this. Okay. Then 48 is the data. So we can just write one key, then it will be, clear for the, uh, person who wants to know about the situation in a stem and leaf diagram. So this is how we can make a stem and leaf diagram. So you see, this is just explanation here. 6 means 06. Okay, according to key, as you know. 2 5 2 bar 5 means 25. So the key shows us how to read the diagram. Okay. So this number is 39. Why 39? Because 9 is against the stem 3. So 3, 9, that is 39. So this value would be what? Say 0, 5, 0, 50. So this value is what? 25. 2 and 5, 25. So this is how we can understand from the key. So now another thing, just last thing for today, that is back-to-back stem and leaf plot. Yeah, sometimes we will be given two sets of data. Two sets. Look, in the previous example, there was just one set of data. But if we are given for two sets of data, say for two class, section A, section B. So this is section A results. Say maybe there would be another set of results for section B. So in this case, if we want to present the results for both the sections, then we have to make a stem and leaf in the same diagram. It is possible by making a back-to-back stem and leaf. Okay, so back-to-back stem and leaf means we will make a common stem here. Then to one side of the stem we'll put the data, and to the left side of the stem we'll just to other side of the stem we'll just put the other set of data, but in the same way. So here we are given just uh, so there are two taxi drivers, Keith and Asif, and Keith were actually drove in a certain month. Um, uh, uh, every day he just drove different miles. Okay, mileage is given for Keith, and also mileage of given for Asif. Okay, how much they drove actually every day. So here, these are actually placed here in the back-to-back stem and leaf. Actually, their data were 3 digits data, I mean hundreds. So rule is always unit place data will be kept in the leaf. Always remember, unit place data would be only kept in the leaf, and the other data, so for hundreds, actually unit place would be kept in the leaf, and 10 and 100 place that will be kept in the stem. So actually this is given, maybe Asif's first data was 184, then another was maybe 184 again, then 185, then 187. Actually we are using the unit place value here, and 18, 19, 20, these the maximum lowest distance of Keith was say 180 miles, and Asif's was 184 miles, and the maximum distance of Keith was 263 9 miles. So that means when we are going to put the make the stem, we have to see the what is the lowest and what is the highest value, and considering that we'll make our stem. So here maybe the table is not given here, just we have the stem and leaf, back to back stem and leaf here. Plot is stem and back to back stem and leaf plot is here. So from here we understand the lowest value was 180 for Keith, and for Asif it was 184, and the highest value of Asif was 254, and it was to 263, whatever. So we have to consider both sets of data, and then we have to find the lowest value from the both sets of data. The lowest one would be considered for the lowest first stem, and the highest value in both sets. We have to see which one is the highest. That would be considered for the last stem. And here, for since it was 180, lowest value and highest was 269, so our stem was written for the unit and 10 plus value 18, then 19, 20, 21 up to 26, and then all unit place value were put for Asif. From data of Asif, we just put all the unit place here against the respective stem, and kids one is also placed in the stem of for kid to the left here. Okay, the key will be written like this. Okay, so if you see, look at the key here, 0 bar, vertical bar, 18 bar, 4 means here 180. This way, left is for kids. So 180 is for kid, and 184 is for Asif. Okay, this is how back-to-back stem and leaf plot is drawn here. And remember, maybe okay, I'll show you in a Zoom class on. I mean, when I'll come online, I mean then when I'll be in live, maybe today. Yeah, today maybe I'll be on live. Then I will just show you how to draw a back-to-back stem and leaf plot. Maybe I will use this example with the real data. Okay. Okay, that's all for today. Thank you very much for watching me, and I hope you have understood. If you have any question, please ask me. I'm there. Uh, I'll be in on live today. Then you may be able to ask me some any kind of question if you have. Thank you very